Now a small numerical on projectile motion. The numerical is like this. A projectile is projected horizontally with a velocity u at c. This is the point C. It is projected horizontally with a velocity u. So it will travel like this. When it arrives at A, find its resultant velocity and the angle it makes with the horizontal. As I have explained you before, when this is projected horizontally to this side with a velocity u from this point, at the instant it was projected at this point, the velocity downward was 0. To this side there was no velocity. After it is released, the earth pulls it, so its velocity increases due to the acceleration g. So when it is at A, let the downward velocity is v1. Let me explain how it is gt. Let t is equal to time to reach A. U remains unchanged, this one. This remains unchanged because there is no air resistance. Now using this equation of motion, v is equal to u plus at, this is used if acceleration is constant. The downward acceleration due to Earth's pull g is constant, so this can be used. For downward direction, v1 is equal to, at this point the downward velocity just at the time of releasing was 0. I am applying this equation for downward motion, not to this side. At this point, when this was released horizontally with a velocity u, at that point the velocity here downward was 0. As it is released, then due to the Earth's pull and this acceleration, it gradually increases. So but initially here it is downward is 0. So it's 0, g plus gt, so that becomes gt. So this velocity v1 here after time is equal to gt. Now we have two velocities, u to this side and to this side is v1. This as well as this, they are both are perpendicular. So the resultant velocity by parallelogram law, take this and this as the two sides of a parallelogram, construct a parallelogram, therefore this is your resultant velocity v1. So since v1 and u are perpendicular, the resultant velocity is v is equal to square of this plus square of this, square root of that is equal to u square plus, instead of v1 I write gt, square of that g square t square, square root. Now let this angle is equal to beta. So in this triangle tan beta will be this divided by this. This is same thing as this. So your tan beta is v1 over u. Tan beta, this v1 over u. That is equal to gt by u. Suppose it is again asked after how much time beta is 45. Suppose. So put beta 45. Tan 45 is equal to 1, that is equal to gt by u. So which implies on cross multiplication t is equal to u over g. So if it is asked after how much time it makes 45 degree with horizontal, the time is the velocity of projection divided by acceleration due to gravity.